Okay, can we go? Okay, good morning, everyone. And first of all, thank to them and to all the team for having us here, presenting Omer. So who am I? My name is Federico Cabiddu. I'm a voice engineer architect, mainly focused on open source solution, as most of us here, I guess. And I'm a voice lead at Libon, a project that is was born inside the Orange French group. And I'm a Kamailio developer and member of Kamailio admin group. And since 2016, I'm part of the QXIP and SIPCAPTURE team, and I'm an amateur bass player. Oops, sorry. So who are we? QXIP or QuickSip, depends on how do you like to pronounce it. Is a R&D development company based in Amsterdam, and we are specialized in open source packet capturing solutions. And our projects include app, the Omer encapsulation protocol, which was designed years ago by Alexander Dubovicov and Lorenzo Mangani, Omer, which are here to speak about, and Epic, the Omer big brother, Sentinel, Pastache, and many other tools that we release for the open source community. And QXIP is an independent, self-sponsored company. And we are growing, and now the team is composed by Alexander, Lorenzo, me, Celeste, Eugen, and Michele, Sergei, and other people contributing. Oops, sorry, I have some problems with it. Okay, so Omer 7. It happens that Omer 7, so the 7th release of our most known product, it's in the 7th year of Omer development. It was not done on purpose, but it's nice. Oops. Shit. Sorry, I have some problems. Okay. So as I said, Omer 7 is the major release of our product. You may ask, what about Omer 6? Well, Omer 6, like the kernel development releases, never seen the light, because there were so much things that we want to put in it that at the end, as I will explain, we decided to rebuild everything. So which was the goal that we set when we decided to start this new adventure? First of all, we wanted to have new captures and new capture servers and agents. So traditionally, capture server in the Omer application has been were implemented with OpenSIPs or Kamailio, leveraging their powerful SIP parsing stuff and a lot of more. But as we were trying to focus on and move away on from a SIP-only world, we needed some more flexibility, and this goes with the second point. We wanted to be able to parse more than net protocols, events and CDRs, JSON objects, and many stuff that are related to the new scenario, new RTC scenarios. And for this, we realized, thanks to Negbi, Eugen, we did a huge job, a new capture server, and independent, ready to run, and portable. I will speak a little bit more after. Another decision that we took was to separate data and statistics. Traditionally, in Omer 5, we store the data for search and statistic in the same backend database, so MySQL or Postgres, with obvious limitation, both in terms of flexibility, but also in performances. And at the end, we were reinventing the wheel for doing something that other projects do really better. So basically, we decided to store in the database only the data needed for search and to turn everything else into time series and use the appropriate backend for this. Another point was to open the integration to non-app platform. So not only to let's say to those agents that have integrated app agent inside, like basically Kamailio, OpenSIPs, Asterisk, FreeSwitch, and others, but also to be able to send and parse other kind of objects. And so now we can receive data using UDP, UDP or TCP, HTTP, Protobuf, which is a new addition, a recent addition. We also wanted to get rid of PHP and Apache Stack, both for the API and for the UI. And so we have a new API rewritten from scratch, developed in Node.js, and a new UI, which is derived from the Big Brother API one. So, major changes of Homer 7. We have two new capture servers. We have the Amplify server, which is written in Go, mainly by NEGB, and is targeted for high performance and more traditional net protocol. So, if you want to parse SIP, use Amplify server. AppHop is the let's say bleeding edge capture server, which is more targeted for the new protocols, new event-based protocols, or a protocol, or targeted to implement to prototyping a new protocol. If you develop your own protocol and you want it to be parsed and searchable by Homer, you can easily implement the parsing with AppHop. So as I said, we have a new web services, the new Homer UI, as I said, is inherited from the Epic, which is the Homer Big Brother, and a new API. About the database, we still use Postgres or MySQL, but in this case, leveraging their native JSON, JSONB indexing capabilities, and this mainly for Postgres. So we kept MySQL for compatibility, also for benchmarking, but it will probably be removed in the future. Probably. There's still an open discussion internally. And the main change in this, as I said, is using InfluxDB or Prometheus as a time series backend. And this is one of the major changes, because not only we can separate data from statistics, but we can leverage their native aggregation and alerting features. For example, for the InfluxDB, you can use a complete tick stack. Okay. So some more details. So as I said, Amplify server is a standalone Homer capture server developed in Go. And you can download it and run it on several platforms. It's distributed. Of course, you can download the source and contribute and compile yourself, but you can also download it and run on several platforms. Amplify, which is let's say the capt agent. Any of you have ever used a capt agent? So you know what I'm speaking about. It's for sure a simplified version of the capt agent, written in C, which are more targeted for, say, ready-to-go scenarios. So you can download it, install it also in a lot of different architectures, and basically having it ready to go to parse SIP, correlate to RTCP, RTCP extended report, DNS, and logs. And last, then, we have the AppHop, which is the other standalone capture server, which is developed in Node.js and distributed via NPM. And besides being able to capture traditional Homer format, so app encapsulated packets, is able to, it's what is used to capture events from Janus, MediaSoup, OpenSIPs, or other RTC gateways. So one major change, that internal change that you may not realize looking for external, is that everything now inside Homer is JSON. So we are using native JSON and using the functionality provided by Postgres and MySQL to be able to basically index and search every kind of document. So we will see then how we are able now to add, and you will be able to add a new protocol quite easily. And also, this fact of using JSON allows us to improve also the correlation. So if you're familiar with Homer, you know the correlation ID, and in SIP you have to pass a special header if you want to correlate two legs. With the new schema that I will show you, you can have a chain of correlation of protocols. So you can correlate a protocol to many other, and doing a search, having a much wider view of what's happening in your system. Oops. Ah. So as I said, time series and alerts are one of the biggest changes that we did in Homer 7. And now the new capture server are able to transform many events and the many events into tagged time series, and that can be pushed then to InfluxDB, Prometheus, or Elasticsearch. And as a consequence, we can use their native alerting system. So for example, Capacitor for InfluxDB, Alert Manager for Prometheus, or Sentinel for that is written by us for Elasticsearch. And okay, I will speak then. We'll see in the UI that this also allows us to visualize with the UI data that are not forcefully produced by Homer. Oh, definitely, I have problems with this remote. Okay, so we have a new fresh user interface. It's probably not really clear in this picture, but it's finally a really customizable dashboard, and that you can share across users. So you can have your own dashboard or dashboard per team, and distribute it across the team. Okay. Also, if you see in the result search, we are not showing. Also, it's not so clear probably. We are not showing anymore only SIP messages, but also other kind of protocol or event that you may ingest into Homer. It will be more clear in the next. No? Just one. Okay. So, for example, here you can see that in the search result we have beside traditional SIP messages also that xlog that are, in this case this is an event sent by OpenSIP, but we can have also CDRs or other kind of event, DNS queries and HTTP queries, all related to your call, which gives you a wider view of what's happening. Okay. Another important, as I mentioned, we wanted also to move from traditional telecom field, so traditional SIP field. And what we are able to track with this new Homer is not only network events, but also internal events of the application. In this case, we have, for example, the case of Janus, where we can track what's not only the network exchange between endpoints, but also internal messages between plugins or events. Oh, definitely. Yeah, and this is, okay. This, for example, is a picture showing how you can integrate your statistic in the Homer dashboard. And just taking account the UI, basically now it can access directly the data from the InfluxDB or Prometheus or Elasticsearch backend. And you could also integrate, for example, your system statistics, so CPU, load, etc. So monitoring the application, the behavior of the application itself. Ooh, no. So just a little recap of what was before. In Homer 5, we had the two capture server and the OpenSIPs or Kamailio, sending via app. So basically receiving via app from the capture agent, and OpenSIPs as a nice app switching mechanism that allows you to proxy, to act as an app proxy. But beside this, what we did was just insert the messages, the packet, one by one on Postgres or MySQL backend. In this case, okay, no, definitely I cannot. So, and now is how it looks like. So we have now, as I said, OpenSIPs and Kamailio are doing the agent part. So they are capturing, they are duplicating their traffic or their internal event to the server, Amplify server or AppPop. And the first step is a switch by app type. So once a packet reaches one on the server, the needed table would be created on the fly by the server. So the packet then will enter a queue by protocol, and they will be inserted by bulk into database. This increases dramatically performances, and something that is tunable by the user. So according to the traffic, to the loads, you can decide the size of those bulks. The other part followed by the packet is about, as I spoke about, the metrics. So each packet is tagged as a metric type, and is pushed or pulled to InfluxDB or Prometheus via Telegraph, which is the dispatcher component of the tick stack. And on the other side, we still have the UI and the API. So as I said, let's see now how we can add a new protocol. Okay. So the table now are composed using the app ID and the profile ID of the call, the profile ID of the message. So if you don't specify any profile ID, you will be using default. But this is what you can use, for example, to separate calls from registration in a SIP flow from default. So the tables now have always the same structure. So we have an ID. Okay, the important part are the protocol header, which is the app protocol with the receive information, let's say the network information, and the data header, which is simply JSON-B object representing your parsed message, and then we store anyway the raw packet as received, because you could do a full text search over it. I don't advise to do it, but if you want, you can. And here, this is the protocol mapping table, and in this table you define some properties of the protocol, like the retention policy, the way you partition your data, but most important, the correlation mapping, which is what I was speaking about before. It's the way you correlate a protocol with all the other protocols that you have, that you want to ingest. So, for example, I'm doing a small example. That it's an example that we did. We can send from both OpenSIP and Kamailio. We can send CDRs to Omer. So, how we can represent these CDRs? So, as we said, first of all, you just have to insert into these mapping settings the relevant values for this new protocol that you want to add. In this case, the app ID, the alias, so a meaningful name, and retention and partition policies. And the derived table will be created automatically by the server, as I said. And this table schema is the same for all the app protocol, for all the protocols. And as I said, what is important here is this correlation, is the correlation mapping column. In this case, we have an example on how we could correlate CDRs to SIP. So we have this JSON object, which is really an array of objects. So what I was saying before, you could have multiple correlation between multiple protocols. In this case, we are saying that of the parsed data header of the CDR, in this case, we take the call ID, then we look on the lookup on the app protocol 1, which is SIP, in the calls profile, and we look up for the field SID, let's say a custom field, and we specify the range to search, just to take in account network delays in delivering messages. And basically, you will have this kind of query automatically built, which is select from app proto, lookup ID is the one you specified in this object, and where lookup field is source field. And you can have an array of these objects, so practically chaining different correlation. Okay, no. So one of the best thing of this of the new UI is that ingesting the protocols in this way allows them to be automatically parsed, indexed, and allow the UI to automatically adapt to new protocols. For example, in this case, we start from the basic SIP search widget, which is still the one that is still present, is already present in Omer 5, and we edit it. And okay, I didn't have a real-time demo, but I'll show you the pictures. You select the protocol, and you see in this, you will see automatically the new ingested protocol recognized by the system. And also all the parsed fields that are present in this CDR. So you can customize your widget. So let's say, for example, we add the CDR row in this case, this result, and this is my fat finger. And this is for example, an example of final form, where you can search for a user, destination user, or even for a duration. I want all the calls with 0 duration in the last 10 minutes. And this you can imagine this for every protocol that you can also invent. If you are developing a new protocol and you are prototyping it, it's really easy to add it to Omer, and so to be able to follow at the same time the development and have an help in the debugging. Okay, just a little schema of how SIP indexing now is performed. So, let's say the app socket that received the raw payload in app, the capture server parse it and extract part of the field that you want, and put it in JSON object. And this JSON object is then pushed in the table in the data header column. And that's it. And this is basically the same for all the protocols. For example, this is how Janus is parsed. In this case, it's not an app it's not sent. The messages are not sent by Janus via a protocol, but to AppOp via a normal plain TCP socket. But then they are parsed and treated the same way, and at the end, we always end up with a data header containing the parsed version of the payload. Just one, okay. And this is how you would see, for example, a video room chat with Janus. Here we have mixed IP addresses with plugin. For example, in this case, this is Janus plugin video room. So internal events are mixed with a network event. Okay. No, that one. I will do it. Okay, so where are we? All the core components of Homer 7 are already available on GitHub. There are also Docker files for Docker lovers, and we are keeping working on it to improve the stability. And everyone is welcome to join us and participate, even just filing a bug. Okay. So at the end, this is the final Homer, the current Homer ecosystem with all Homer and his friends. So we have the newcomer Janus and Media Soup, and the traditional part on the left. On the right, we have all the languages for which you can find an app library, and then 2 new capture servers on the base. And you can find, as I said, all the source code in GitHub and the SIPCAPTURE, and you can visit our 2 main sites, sipcapture.io and epics.tel. That's it. Any question?
Sorry, I've got a couple of questions. With FreeSwitch, if you're using TLS SIP with HTTP, will FreeSwitch decode the SIP so that you can actually send that into Homer?
So FreeSwitch has its native HTTP, app support. You can capture TLS and decode, but it really depends on what you are using as an encryption key. For example, there's no point if you are using Diffie-Hellman, or luckily it's not possible to capture passively.
So do you know if FreeSwitch decodes the SIP traffic first before delivering it to Homer? It does.
Yeah.
And does Homer support MariaDB?
Yeah, it's MySQL or MariaDB. But as I was saying, it's not sure that MySQL will stay longer.
So besides HEP, you said your build is more for publishing information to different protocols, like Protobuf. Will HEP still be there?
Yeah.
What are the other options I've seen? Protobuf?
Yeah, Protobuf is the last addition from Alexander, and I personally haven't played with it, so I cannot say much. But for example, in Pastash or AppOp, you can have also 0MQ socket for receiving. We are using it in a couple of cases, or direct HTTP interface, if you wish.
The payload is JSON or some other format that is defined?
This depends. In the case of Janus, for Janus, it's sending something already pre-formatted. Otherwise, you can do it on the server side on AppPop. It's quite easy to parse and add new protocols. And that's the place where we introduce new protocols. That's it.
So what is the preferred database for
Postgres, definitely. Sorry?
So version 5, if I remember correctly, preferred MySQL.
No, version 5 was there was no difference between MySQL and Postgres, but at the end, probably most of the deployment were done with MySQL. But from this last development, so mainly working with JSON object, we've seen that Postgres has something more than MySQL. And probably we will reach a point where we won't be able to do the same thing with Postgres and MySQL. So this is still an open point.
So then for the new capturing server, it's doing only Postgres, or how it's when it's writing now?
The new for the moment, they are writing in both. It's up to the user to.
It's using like module because it's a Golang, right?
Yeah.
One of them. So because with Golang in the past, only recently they added the option to use modules. So now it's like build with bot support.
It's built. Yeah, it's built. Yeah, exactly. It's built with both support. Then, if you want, you can compile yourself and get rid of one of them, just to have a smaller binary. But
No, I was just curious if you went for the module, how they call it, because I think they support now the latest Golang, at least for Linux, you can have this sort of modules.
yeah, I'm not. I don't know where.
Because you had two now, it was the one on Node.
The one in Node.js, yeah, the one in Node.js is it's clearly modular.
Yeah, I know. But how it's like seen now between the two of them, which one is kind of preferred for the other, or?
It depends on the application. If you are on the let's say, legacy SIP traffic, let's say legacy, better use Amplify server because it's more tuned for performances, etc. If you have some new protocol, which may at the end enter in the Amplify server, but if you want to prototype something quicker, or if you have something that is changing, like most of the WebRTC stuff today, it's easier to use AppOp, which, by the way, quite good in terms of performances, even if it's Node.js. Okay. Thank you.